In this video, we will be discussing compound events, like what's the probability of two things happening at the same time or two things happening in a row. So there are a couple of concepts that come up. One is the question of independent versus dependent, and the other is the question of mutually exclusive versus overlapping. Mutually exclusive versus overlapping, that's really easy. If you look at a Venn diagram, if two events or if two sets are overlapping, they will literally look something like this, all right, with the overlapping circles, showing that they have something in common. There are some elements that belong to both sets at the same time. That's what overlapping means. Mutually exclusive sets would be two groups that have no overlap, right? There are no members of these sets that are in both sets. Okay, so that's going to be simple enough. Now, when we talk about independent versus dependent, that's a matter of testing with a formula. So here's the formula for independent. All right, if the probability of event A times the probability of event B is equal to the probability of A and B, if that's true, then it's independent. So maybe next to this I'll put true for independent. If this equation is false, then that means that the two sets are dependent. Okay, anyway, let's do some problems and see how it turns out. So we've got this deck of cards. There are 10 blue cards numbered 1 through 10. Similarly, there are 10 green cards, 10 red cards, 10 yellow cards. So there are 4 colors, and each set is numbered 1 through 10. So cards are drawn from the deck described above with replacement. All right, that means that we take out a card, but then if we have to draw a second card, we put the first card back and we start fresh with a fresh deck. All right, so when you see with replacement, that means that it's going to be independent, because if you start over each time, your first draw will not have any effect on your second draw. So those will be independent of each other. Now, find the probability of drawing a green card, then drawing a 9. All right, you replace the card between draws. So that makes it independent. So that means we should be able to use this independent formula. All right, so we're being asked to find the probability of drawing a green card and then drawing a 9. So that means the probability of green. Oh, okay, we're supposed to use A for green and B for drawing a 9. So my bad. So that's the probability of A, okay, times the probability of B. All right, and again, I'm just multiplying because the probability of both of these things happening in a row, we're supposed to multiply according to the formula. So what is the probability of drawing a green card? Let's see. Well, there are 10 green cards. I'm thinking target over total. So there are 10 green cards out of a total of 40 cards. Now, what's the probability of drawing a 9? So how many 9s are there? Well, there's one for every color. So that means there are 4 9s, so that's the target. And again, there's a total of 40 cards. So this is the probability of drawing a green card. This is the probability of drawing a 9. If I multiply those together, that's going to tell me the probability of green and 9. Okay, so look, if I just multiply these together without reducing anything, that's going to give me 40 over 1,600. Okay, but if I were to reduce this, this would reduce down to 4 over 16, which is 1/4. Sorry, I messed that up a little. This would reduce down to 4 out of 160, so that would be 1 out of 40. All right, so any one of these could be the answer. Now, part B. Cards are drawn from the deck described above without replacement. Okay, so this time it's going to be a little bit different because we're not putting the card back. So find the probability of drawing a blue card and then drawing a green card. Okay, blue card and then green card. Okay, so we need to find the probability of drawing a blue card and then drawing a green card. Okay. So here's how we have to modify the equation a tiny bit. I can't just say the probability of A times the probability of B. Okay, because these events are not independent, because we're not putting the card back. The second probability will change. So here's how you fix it. You say the probability of B given that A has already occurred. Now, here's what I mean by that. The probability of A is going to just be normal because A is being drawn first. So what's the probability of drawing a blue card first? Let's see. There are 10 blue cards, so target over total. So there are 10 blue cards out of a total of 40. So that's the probability of drawing a blue card first. Now, what's the probability of drawing a green card second? Okay, well, how many green cards are there at this point? Well, there are 10 green cards still, so that's going to be 10. But think about the total. Focus on the fact that we did not put the first card back. We took out a blue card and we did not replace it. We did not put it back. So that means the total is going to change. So instead of being 40, it is now going to be 39. All right, so that's what you have to do. So we're still just multiplying the two probabilities together, but you just have to be careful about the second probability because if you don't put the cards back, the second probability is going to change. Anyway, so let's multiply these together, and that's going to be 100 over whatever this is. Okay, and you could reduce it if you wanted to. All right, 5 over 78. Okay, let's keep going. One card is drawn from the deck described above. All right, so event A is drawing a card with a 3 on it. Event B is drawing a card with a 7 on it. Okay, are these events mutually exclusive or overlapping? Okay, well, we're drawing one card. Is it possible for that card to be both a 3 and a 7 at the same time? No. All right, that means these events are mutually exclusive. Both cannot happen at the same time. These events are mutually exclusive because one card cannot be both a 3 and a 7. Okay, now find the probability of drawing a 3 or a 7 in one draw. Okay, so probability is target over total. Target over total. Okay, so the target is 3 or a 7. So let's see, how many targets are there? Okay, so how many cards are there that are 3s or 7s? Let's see. There are 4 3s and there are 4 7s. So that's going to be, there are 8 targets. All right, there are 8 cards that are either a 3 or a 7. And of course, the total number of cards is still 40. So right there, that's the probability. I would accept that answer. You could reduce it if you wanted to, and that would be 1 out of 5. You survey your classmates about which high school sports games they attend. A is they attended at least one football game last semester. B is they attended at least one basketball game last semester. So football, basketball. Are these events mutually exclusive or overlapping? Explain. These are going to be overlapping because there will be people, or there could be people, who, attended a football game last semester, and they also attended at least one basketball game last semester. All right, it's possible for the same person to attend a football game during the semester and also a basketball game sometime during the semester. So again, I could say these events are overlapping because it is possible that some students attended a football game last semester and also attended a basketball game last semester. All right, moving on to part E. You survey your classmates about what they did for winter break. Half of your classmates are female. Only 20% of your classmates left Atlanta. 15% of your classmates are female and left Atlanta. Let A be the event being female, and let B be the event of left Atlanta. Are events A and B mutually exclusive, or are they overlapping? So remember, we're just asking, are these events like this? Okay, and this would be A and B. Or are they more like this? A and B. Well, most of this problem is just a distraction because the answer is very quick and obvious. These will be overlapping because they have a portion in common. There are some students that are female and left Atlanta, and they are right here in the problem. 20% of your classmates, nope, that's the wrong one. 15% of your classmates are female and left Atlanta. All right, that would be this overlapping portion right here. So they are overlapping. So these events are overlapping because some students, 15%, are female and left Atlanta. All right, so for part F, we're supposed to come up with our own pair of mutually exclusive events. And I'm going to skip over that because I want you to come up with your own. Here, I'll verbally say an example to you, but I'm not going to write it down. Let's say one event was being 13, and the other event was having a driver's license, in America. I guess I'm not sure what all the laws are in all of the countries, but so let's say in the United States. Those events would be mutually exclusive because you cannot both be 13 and also have a driver's license in this country. All right, come up with your own pair of overlapping events. So one event could be being a resident of the state of Georgia, and the other event could be having a driver's license. Those would be overlapping events because you could both be a resident of Georgia and have a driver's license. So those would be overlapping events.